Students, in our previous class, we have discussed about how the number of electrons or number of valence electrons will be for different types of materials. So we have seen for conductors, for semiconductors, and for insulators, what will be the number of valence electrons, and how we can make out looking at the valence electrons count, and how we can classify them into different categories of conductors, semiconductors, and insulators. And we ended the previous class with the silicon materials or silicon semiconductor materials orbit pattern, isn't it? So today we will see for germanium too, or GE. It has got the what is that atomic number. What is the atomic number? Atomic number will be, it is what? It is 32. So atomic number will tell us what idea with the atomic number will tell us. Atomic number will give us the idea of what? It gives us the idea of what? Number of electrons or number of protons, and number of electrons and protons will be equal to make an atom electrically neutral. Okay, yes. So now we'll see for germanium. So atomic number is what? 32. So for this also, so you might have tried this at home. Otherwise, like I'll be doing it for germanium too, because they have only the best semiconductor materials which will be used as for building all our electronic components will be either silicon or germanium. Silicon will be preferred more than germanium because it has got many advantages over germanium, because it can resist a lot of heat, lot of temperature it can take. So that is one of the best advantages. So now we will see for germanium too. So we have seen for silicon, isn't it, in our class video, and now we will see for germanium. So first orbit, or we will start from the nucleus. So we have nucleus. So shaded portion. Okay, it has got protons and neutrons, isn't it? Yes. So first layer will start. Our first orbit will start. First orbit can have only 2 electrons, right? Yes. So then we go for the second orbit, wherein we can have how many electrons? How many electrons are possible on the second orbit? 8, right? So we have 8. So now how many are done? 2 plus 8, 10 are done. So our number of electrons is what? 32. 10 are done, 22 remaining. Okay, yes. So what should be the final conclusion? The outermost orbit must have how many electrons? Only 4 electrons it should have. Then this material is what? A perfect semiconductor material. So valence electrons count should be what? Exact 4. Then that material or that matter is called as what? Best semiconductor material. Okay, yes. So now it is done. So 10 are done. So we will go for the next orbit. Now here is the third orbit. Till now we have seen, like in our examples and all, we had we have considered only 2 of the orbits, isn't it? For example, yes. So now the third orbit also has come. Okay. So now third orbit can have how many electrons? So it is what? 2n square. That will result to what? 18 electrons, isn't it? Yes. Isn't it or not? The formula is what? 2n square, isn't it? 2 into 3 square. Okay. So 9 2s are 18, isn't it? Yes. So 18 electrons will come on the third orbit. So we'll write 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So this side 9 will have, this side another 9 will have. So that will result to total 18. 15, 16, 17, 18, 19. Total of 19 electrons are there. So how many are done now? 10 plus 18, 28 are done. So 28, and how many are remaining? How many are remaining? 32 minus 28 if I do, remaining are what? 4. So the outermost orbit or the valence orbit, here it is fourth orbit, will have how many electrons? Only 4 of the electrons it will have. Done? Okay. So this is how I can have the germanium material or matter as what? A best semiconductor material, and here it shows 4 of the valence electrons, says that this material is what? Semiconductor material. Okay. Yes. Now we will see how the electrons will move from one atom into the other atom. So let us consider a copper wire. So now we have a copper wire. Fine? Yes. So now we will go directly, like I will consider some point here in the copper wire. So copper wire is what? It is a conductor wire. Okay. So let that be a conductor or semiconductor. So it will have the smallest particle as what? Atom, isn't it? So here at this particular point, I will consider, I will enlarge this portion. I will enlarge this portion. Okay. So here I consider at this point or any point I can consider. So I will be having atoms, isn't it? So I will draw on 3 atoms. I will be drawing. Okay. So central nucleus. So then 2 orbits. Then I will have another thing. So then I will have another thing. Fine? Yes. So likewise, so there will be many atoms. I have drawn only 3 of them. I have drawn. Okay. Yes. So now there will be like nearby. Okay. So it is nothing like there will be gap in between. Okay. So that's why I will be solving. Okay. Now listen. So now have considered 3 of the atoms. Okay, fine. Yes. So now we will see how the things will be. So semiconductor material, isn't it? Like or we can say not semiconductor. I can have any number of things. So I have said that this is a copper conductor. So we will make the atomic. How many, like what will be the valence electron count? Either it will be 1 or 2, isn't it? So we take it as 1. Here I will be taking another 1. Here I will be taking another 1. So it has got 3 of the atoms I have shown. So wherein we have the valence electrons as what? 1 electrons we have on the valence orbit. So now I will be like we will be seeing how this is going to happen. So now what I do is, this copper wire has been connected to a battery. This copper wire has been connected to a battery source which has got a positive terminal here, negative terminal here. Negative terminal in the sense ground potential. Okay. So then I have put a bulb over here. So that bulb glows whenever this battery has been supplied to this. So bulb will glow. Okay. Fine. Is that okay? Yes. So when I have given this battery source or voltage source, we call it as what? Voltage source, or I call it as what? EMF, isn't it? Yes. Okay. So now this is your bulb. Fine. Yes. So what I have done? I have a copper wire which has been connected to a battery source. So this bulb glows. So here, when this voltage has been applied, so here starts the current flow in this wire. So that current goes from this end, it goes here, it goes here, and it goes back to negative potential. So everything should go to ground, isn't it? So it will start from here, it goes like this and like this. It will go back to earth, and this is how I can have a closed loop or closed path. And we have already said this, current only flows in a closed path circuit, or in a closed path the current flows, otherwise it will never flow. If there is any cut in between, so current will never flow. Final point. Okay, so because it needs a path to, or continuous path to make your charges to move. So electric current is nothing but the motion of charges, isn't it? Continuous flow of charges will make electric current. Okay, fine. Yes, so the charges will be moving and current will be moving in a closed path, and always current flows from positive of the battery. Current flows from positive of the battery and comes back to what? Negative of the battery. Okay, always the voltage sources positive terminal. From the positive terminal, the current starts to flow and it comes back to the negative terminal. It loops back to the negative terminal. So this is how the flow path of your current will be, and current will be indicated by the symbol I, capital I, and voltage will be indicated by letter or capital V. Okay, yes. So now here I have said about current. Current flows from positive of the battery and goes back to negative of the battery, and there must be a closed path. There must be a what? A closed path for the current to flow. Fine? Yes. So here in this conductor copper wire, so I have taken a point wherein I have drawn only 3 of the electrons. So we will see how this motion of charges will be. Fine. So how the charges will be circulating and how the current starts to flow. So that idea we have to have, isn't it? Yes. So now, like I said in our previous class about the charges. Okay. So charges. So what is the first point about the characteristics of charges? So what is that? Like charges and unlike charges we have talked about, isn't it? So what are like charges? Positive are like charges, negative are like charges. If I have positive negative charges, then these are unlike charges. Unlike means what? Not same. Not same charges. So one charge is positive potential, one charge has got negative potential. So then these charges attract each other. So unlike charges attract each other, or like charges repel each other. Unlike charges attract each other, like charges repel each other. So this will be the setup. So this is how the things will be. So here now coming to electrons. Electrons are what? What are they? They are negatively charged particles. Electrons are what? Negatively charged particles. So then I have connected a battery or EMF source, electromotive force. So here there is a force of attraction towards what? Towards what? This battery. So this battery has been connected to make the electron motion force. Okay. So this is how I will be giving this battery or source of EMF or charge or voltage I have given. So because of this voltage, so the bulb glows, and when the bulb is going to glow, so when the current flows to the bulb, and that happens with the current. And now we will be seeing how the current is flowing. Okay. So here there is a positive terminal. So now here we have what? Negative charges. Here there is a positive potential. So then here we have what? Negative charges. Negative charges is electrons. So what electrons will experience now? So positive and negative charges or unlike charges attract each other, isn't it? So here we have a negative charge. So obviously it will be attracted towards what? Positive of the battery, isn't it? Correct or not? So this negative charge will be attracted towards the positive of the battery. So then what happens is, so these charges starts to move towards the battery. Okay, so what happens here is, so until unless this electron on the valence orbit gets a force of attraction towards any of the side, so until unless it gets some energy to jump, it won't jump, it will be there in the orbit. So sometimes if we increase the temperature, because of temperature rise also, some of the electrons will have that energy to jump from valence band into the valence band of another what we can say atom. So from one atom charge will be moving on to another atom. Okay, fine. Yes. So here there is a positive charge. So here there is a huge positive potential. So these electrons obviously will be attracted towards the positive of the battery. So what happens here is, so this electron first, I will be considering first atom's electron. So this electron will experience a force of positive potential. So that what happens to this electron is, so this electron will jump from here to the next atom, which will be there side by. Okay, so then here there won't be any electron now. Fine. Okay, so because of absence of electron, there will be another charge which will be created. So that will be dealing in our next classes. Okay, so in our further chapters we will be consider that. Okay, yes. So now what happens is, this electron has come here now. Okay, so what happens to this electron? Again, that will be experiencing a force of attraction towards this, isn't it? So this will be shifted here. This electron will be shifted here. So that will come here. And what about this? Even that gets the force of attraction, isn't it? So here there is an absence of electron now. So this electron will come and sit here. Fine. And here there will be a vacancy of electron. So that will be supplied by the next atom. Likewise, charges will be moving from one atom into another, one atom into another, one atom into another. Likewise, the charges will be moving from one atom into another. So this is how electrons will be moving from negative of the battery towards positive of the battery. So charges, see, negative electrons are moving from which direction? Negative of the battery towards what? Positive of the battery, isn't it? All the electrons are moving towards positive of the battery, isn't it? So this is a continuous process. This is a continuous process which will be moving like this. From negative of the battery, all the electrons will be circulating. So when they will reach here, again they will be shifted down to negative and they will be circulated. It will be something like the water fountains which will be kept in some shopping malls here and there, in some in our Ganesh festival they will be putting some decorations and all. The water fountain, what will be there, the water will come, the same water will be circulated, isn't it? It will flow, like it will fall, and the same water will be circulated as a fountain, isn't it? In the same way, so the charges, electrons will be moving to positive of the battery, again they will be shifted to negative of the battery, and again they will be circulated. Likewise, the total current will be flowing, and negative charges or electrons will be flowing from one atom into another atom. This is how the circulation happens. So this is how the charges will be circulated, and here comes the actual thing. And what we can say is, current always flows in the opposite direction of the electron movement. So the electrons or the charges which will be moving are what? Electrons. Electrons will be moving from negative of the battery towards what? Positive of the battery. And when these electrons are moving from negative of the battery from positive of the, into the positive of the battery, now we can say that charges are moving. So this is nothing but your current. So this is the current which will be moving from positive of the battery towards what? Negative of the battery. So the current motion is always in the opposite direction of the electrons or charges movement. Okay, so this is how we can have the current which will be flowing in the circuit, and here we have the bulb glowing and the task is done. So what is our meaning here, and what we have done this circuit? So to make your bulb glow, so I have connected a battery, so our task is getting done because of the flow of charges. That means what? Flow of charges. That means what? It is nothing but your flow of current. So current will be flowing into the source, or we can say the load from source to load. So this bulb, which is the thing which is utilizing the current, or the thing which is utilizing the current, is called as what? Load, we will call it as. We'll call this as what? Load. The thing which is utilizing the current is called as what? Load. And from where the voltage being supplied, that is called as what? Source. So here we have source, here we have load, load being bulb, source being your voltage source. It can be either AC voltage source or DC voltage source. I have put a DC voltage source. Okay, so now this is how the current will be flowing from one atom into another atom, and that will make electric current to flow. And now tell me how we can say. So if I have connected some 5 volts battery. 5 volts battery means what? So what we can say? Let me say nothing. So I haven't said about the units and all, isn't it? So we will consider all those things in our future classes. Okay. So now what will be the thing? What will be the thing? So if I have something like a fan regulator, I have. So if I increase the numbers, what will be the speed? Speed will be increasing, isn't it or not? Correct or not? Okay. So if I'm there in the speed 1, so fan will be rotating. If I go for the number 2 speed, so the speed will be little bit more, isn't it? So likewise the speed will be increasing, isn't it? So as I rotate the regulator, in the same way, if I increase voltage more and more, what will be the thing here? The electrons will get more attraction, isn't it? More and more attraction will be for the electrons, and electrons starts to flow more and more. Like more and more electrons will be moving, isn't it or not? So more and more electrons will be moving. So that will make what? More and more current. So more the number of electrons, more will be the current. So this is how we can have more the voltage, more will be the current. More the voltage, more will be the current. So that means more current means what? More number of charges. Like many charges are moving. If I provide less voltage, less charges will be flowing. More charges are flowing means what? More current. Less charges are flowing means what? Less current. So that's all, isn't it? Okay. So this is how we can go for the voltage, current, and this is being a very simple electronic circuit wherein I can have a voltage source and a bulb which is connected with copper wires. Okay. So copper wires are the conductor materials which has been used for making the voltage available at the load. Okay. Yes. So this is how we can have the charges motion. Only the valence electrons will be moving from one atom into the other atom to make the electric current. So now here is the brief idea of how the current is flowing. Okay. So more number of charges means what? More is the electric current. And coming to DC voltage source and AC voltage source. So DC voltage source in the sense. So as we have discussed this one in our previous class. We have discussed about the AC and DC voltage sources. Alternating current and direct current we had talked about. Alternating current is what? The current which will be changing its direction continuously. Fine. Yes. So it has what? It will be changing its direction, and also the magnitude will be changing. Sometimes the current will be positive, sometimes the current will be negative. And direct current is something which will not change its direction, or direct current in the sense what? So it is always positive or always negative. So it won't be shifting from positive to negative or negative to positive. Okay. So it will be always, if it is positive, it will be positive always, and its magnitude will be magnitude will be same. If I take some 5 volts of voltage, if I consider 5 volts of voltage, so then it will be 5 volts. So if I have a battery cell, you might have seen like 5 volts battery cell we will be talking about. Okay. So if that is 5 volts, it will be 5 volts till end. Okay. So when it gets over, then it is done. Okay. Yes. This is how we can say for. So there won't be any shifting of the charges, or potential will be fixed. So this is why it is called as what? Direct current, we can say it as. So this will be a DC voltage source. which will be denoted somewhat like this, and we will denote this in the form, I have shown this in the form of battery. So in our circuit we will be showing this DC voltage source in the form of what? The equivalent circuit symbol for your DC voltage source will be somewhat like this. What I can write is, so we can have two of the lines, one will be larger and one will be smaller, and this is the positive potential and this is what? Negative potential. One is what? Positive potential, another one is what? Negative potential. So this is how the circuit symbol of your DC voltage source will be so and so. This is your circuit symbol. Circuit symbol of your DC voltage source will be so and so. So this is your DC voltage source. The larger line is a positive terminal and smaller line is what? Negative terminal. And this is how we will be denoting in a circuit. Always so voltage sources will be denoted in the form. So we won't put like a battery thing and we will show in the circuit. The things will be shown in what? A circuit symbol wise in a circuit. Okay. Yes. So this is how the DC voltage source will be shown. And for an AC voltage source, the circuit symbol will be so it will be denoted in the form of a circle. So as we have said, and here we will be showing something like this. Here we will be showing something like this, or else we will write this as what? Some positive, negative. We will be writing in this form, or we will denote it in the form of what? A wave, which indicates what? The polarity or the direction or magnitude changes, or magnitude changes continuously. Obviously in AC magnitude changes and also the direction changes. So for that thing we will be denoting it in the form of what? A sine wave. So this is what? Sine wave. Okay, fine. So this is a sine wave and this is how we will be denoting your AC voltage source, wherein the potential here I can't say this is positive, this is negative. Why? Because this is how we have the AC voltage source, because the polarity, sometimes your voltage will be positive for the first cycle. What we can say this as what? Crust, and this as what? Trough, isn't it? Yes. So if I go for this half of this particular one cycle, these things will be dealing in further classes. Okay. So this for the first half cycle, what we can say, this will be positive, this will be negative. When I cross from 0 downwards, if I go, so then this will be negative and this will be positive. Okay. So this is how we can go for the circuit symbols of your DC voltage source and AC voltage source. And DC voltage source will be denoted as a circuit symbol in a circuit so and so, and this will be a AC voltage source circuit symbol. And herein we will be dealing with the DC voltage source more in like in our beginning chapters and all, and further on we will go for AC voltage source in our later on chapters. Okay. So now this is all about your the current which will be flowing in a circuit by the application of what? A voltage source, and we will have a load which utilizes the current, and so the current flows. Without a load we can't have a circuit, so there should be something which will be taking it. Otherwise the thing is something like the voltage will be utilized and again it is given back to the source only. So what is the use? So there should be a utilization. So this is how we have to have a load. Load is what? The device which is utilizing the current, and voltage source is the thing which will be making the current to flow, or it will be the thing which will be making the charges to flow, and finally the current flows with the motion of charges. What are the charges? Electrons are the charges which will be moving from one atom into another atom when the potential has been given. So when the potential has been given, the charges starts to flow. That's all about today's class. In our future classes, they will be dealing some more of the important things, and we will be dealing with about current, voltage and their units, and we will see for the different like how many electrons will be present for some amount of current. So that kind of things will be considering the next class. So that's all for today's class. Thank you.